All right, good afternoon, everybody. My name is Dalton, and I'm going to be giving you a 6-minute talk today about hot dip galvanizing, specifically the dipping portion of the process. What is hot dip galvanizing? Galvanize is basically you cover steel in zinc to protect from elements, rain, salt water, anything to prevent rust. It lasts anywhere, ideally it lasts forever. They typically last 40 to 50 years before it starts wearing off. But when you see it, you really think of it as more of a coating, you know, like say covering something in full. But in reality, the zinc actually bonds with the steel itself, and it's not so much a coating as it turns into part of the structure that you're going to be galvanizing. So a little bit more about galvanizing. The coating has 4 different layers. It's gamma, delta, zeta, and eta. The gamma layer, or there's base steel, which is iron. Then above that, you have your gamma layer, which is going to be 75% zinc and 25% iron. Then above that, you have delta, which is 90% zinc, 10% iron. Zeta is 94% zinc, 4% iron, and then the last layer, which is eta up here, is going to be 100% zinc. And that also kind of factors into the longevity of it, because think about it, if you only have, you know, through your process, if you stop at delta, well, the iron in that layer is going to rust. So you have to make sure that you leave your steel in the zinc bath long enough to get all the way out to your eta layer. So this is, the way they do this is zinc. This is zinc ingot. It's put in it's called a kettle, but it's really just basically a large metal bathtub. And they drop it down into a furnace. It's completely insulated, and these are the burners. And you actually have to rotate these on a year, on like a 5-year basis. But what it is you have a thermocouple that goes into the kettle that senses the temperature of the zinc. And that they're usually at this point they're all PID controlled, and that turns the burners on and off as needed. It's all sealed in, so the gas burners heat up the area that surround the kettle, and that's what brings the zinc up to temperature. Typically, you're going to use, if your steel, say, is 100,000 pounds in a day, which would be low, but you want to have about 3% adherence. So you'd only be around 3,000 pounds, but at $1.50 a pound for zinc, you really want to be kind of conservative with that. So the process to galvanize the steel has to be pure in order to be galvanized. So it has to go through a pre-production process, which depending on where you are, it's going to vary between, you use hydrochloric acid or sulfuric. Sulfuric is going to have to be heated, but it's two different methods that they eat the rust off of the steel. That way you get a clean surface. You also have to run it through it's called a degreaser, which is going to be anywhere. It could be a weak acid or a caustic soda. That's going to eat any tool or grease off of the steel, so that the zinc will actually stick. You also have some scale and stuff like that from the rollers that you make on your beams and such. But once you get all that off, I'll talk a little more about this later. But recently, some companies have started heating their steel up in like a dryer, which is basically a giant oven with a conveyor belt in it. But that really helps for safety reasons, and it helps the zinc stick better. Or you can set it on the ground and then put it in zinc wet and blow zinc everywhere. But either way, that's what a lot of people do. So once the steel is ready to be galvanized, the product is lowered into the zinc bath, and from there the zinc starts to bond with the steel. And when you see it, once it stops bubbling, that's when it's ready. And depending on the weight and the size of the product, that can take anywhere from 1 minute to 30 minutes for some of your heavier beams. And once that process is complete, you have a weather-resistant galvanized coating on the outside of the surface. So related to heat transfer, there's several obviously with the furnace itself, but with focusing on the dip of the product itself. The zinc is kept at 850 degrees, which sounds really hot, and it is. But when you think about it, it's four times as hot as boiling water. So that's kind of for perspective. But once the steel goes into the zinc, there's something known as flux that goes on, and that burns off and creates ash that floats to the top. You have to remove that. But really, once it gets down into the zinc, that steel sucks up all of that heat and the zinc starts to bond. But something that we've found recently is that the hotter the steel is when it goes in, the better the zinc will actually stick. So it does you much better to heat your steel up. That way your heat transfer rate can be lower. Even though your heat transfer is going to be slower, it actually speeds up the process at which you can get your coating on there. So that's pretty much the basics of the hot dip galvanizing. Anybody have any questions? Awesome. Thank you.